Okay, in this second tutorial, we're going to look at the other two objectives. We're going to be able to state the local maxima and minima and state the increasing and decreasing intervals for our functions. So let's flip over to example 3 in our notes. We have a graph again of f of x. So here it is, and we've got a bunch of things that we're going to read from this graph. Let's start with roots. Let's look for the roots first. The roots are right here, right along the x-axis, here, here, and here. I can also tell graphically that there's no sort of multiplicity other than just straight through. So these are just single roots. Let's name them. 1, 2. This is -3. And -1 and +1 and 1, 2, 3, +4. I'll do those in blue. Those are my roots. Let's do our y-intercept. Our y-intercept is just where it crosses the y-axis, and it's right here down 1, 2 to -3. We can put that as an ordered pair, 0, -3. This tutorial is talking about local maxima and local minima. Maxima is the plural of maximum, so we're ultimately looking for how many different maximums there are. We don't say maximums, we say maxima. What a maximum is a highest point. What a local maximum is if you can localize an area such that there is a highest point, then that's what's called a local maximum. Right here is one of our two local maxima. I know that there's another one over here at this peak, and I understand that this second one is higher than this first one, but it doesn't matter which one is higher. They're both called local maxima. This one is a local, it's sort of like an area code. In this area code, we have a highest point, and in a different area code, we have another highest point. So it's just based on your locality. That's why we call it a local. It's an ordered pair, so -2, +3. -2, +3 is one of them. The other one is 1, 2, 3, 1, 2, 3, 4, 5. +3, +5. Please always answer as an ordered pair. The local minima, minima is the plural for minimum, so we're looking for any lowest point. And I see a lowest point right here, and that's actually the only one. It happens to be the y-intercept. So there's my local minimum. 0, -3. I don't see any other ones. This arrow goes all the way down here forever, so there's no minimum that way, and this one goes down there forever, so there's no minimum this way as well. So there's only one little thing. Okay, please always answer as an ordered pair for your minima and maxima. Okay, next let's talk about increasing and decreasing. I know that you know what increasing means. And again, we read our graph from left to right. Increasing means that the graph is going up. So we're increasing right now. When we get to this maximum, we start to decrease and we go down the roller coaster this way. We decrease, decrease, decrease until we get to this minimum. And then we start to increase again and we go up for increasing. And then we get to this maximum. And then we start to decrease, 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 decrease the rest of the way. We need to describe these intervals. And to describe these intervals, we need the x coordinates of what's happening. It has nothing to do with the y coordinates. It has everything to do with the x coordinates. So let's first start with this. We know that we're increasing. We're increasing, increasing, increasing until we get to this value. This value is right here on the x-axis. I thought I changed color. We are right here on the x-axis. So we're increasing from here up to here in the x-axis. We're talking about this interval of numbers. Really, it goes on forever from -infinity. So in fact, we're starting from -infinity. We're increasing all the way until we get to -2 on the x-axis. That's actually our first interval where we're increasing from -infinity to -2. Now, then we decrease for a little bit. We decrease, we decrease, we decrease. And then after we get, or once we get to this point, we start to increase again. We increase all the way to here. So we're increasing from this x coordinate to this x coordinate. And there's another increasing interval for between these two x coordinates from 0 to 3. So there's our other increasing interval. And since we have two different increasing intervals, we put what's called a union symbol in the middle. It looks like a U, kind of looks like a parabola, I guess. It's a union symbol. And that just means that we have multiple intervals that we want to link together. So it's these two intervals. So this interval of numbers from negative infinity to negative 2, and then this interval of numbers from 0 to 3. Let's see if we can do the same thing, but this time for decreasing intervals. Decreasing intervals, that's the interval of numbers where we're going downward, like down a roller coaster, down a ski slope. We're decreasing from here to here, but it's not this point to this point, it's really this x coordinate to this x coordinate. We're talking about this interval of numbers right here. And that interval of numbers starts at negative 2 and goes to 0. So negative 2 to 0 is our first decreasing interval. And then we're increasing, increasing, increasing. We already knew that. But once we get to this point, right here at 3, we decrease the rest of the way. So this entire interval of numbers here, all the way to positive infinity actually, we start at 3 and we decrease the rest of the way to infinity. So I'm going to union this and do another interval from 3 to infinity. Again, that's a union symbol. It looks like a U. That's how you do increasing and decreasing. I understand that a lot of people's eyes are going to be distracted by that they're way up here and then they're going to be way down here. Try not to look up and down when you're talking intervals of decreasing and increasing. We're talking about side to side. Where is the graph decreasing? And it's between this x value and this x value. It has nothing to do with the y coordinates. Has nothing to do with the y coordinates. These are all x coordinates. All x coordinates. If I could spell coordinate. One last thing, we're always going to be using parentheses when we're talking about increasing and decreasing. We will never use brackets. I don't care if it's a solid dot or not, you're never going to be increasing or decreasing at a single point. It's always over an interval of numbers. So please always use parentheses. Only parentheses. Okay, let's talk domain. Domain is all your x values. And I know that this arrow is pointing all the way to the left, and this arrow is pointing all the way to the right, and we have everything in between. Our domain, like every other polynomial, is all reals. You can say negative infinity to positive infinity, or you can say the set of the real numbers. The little braces there. Let's see the range. The range, this time we're looking up and down. And I know that these arrows are both pointing all the way down. So I know that the range is going to start at negative infinity. The question is, how high does it get? Negative infinity all the way up to, well, let's see, here's a high point, but the highest point is this, and that's where the range stops. That's 1, 2, 3, 4, 5. It doesn't get any higher than 5. Now, when you're talking domain and range, you can use brackets, and in this case we have to because 5 is included right here. We've done that before. Our end behavior, we've done this. So both ends do the same thing. So again, I'm going to try to be efficient and describe both ends, the positive side of infinity and the negative side. And this is, it says f of x here. So we're talking f of x. And in this case, f of x is going down in both, on both ends. So negative infinity for our end behavior. Okay, last question. Write it in factored form. Let's write f of x into factored form. Well, first of all, I'm going to leave a little bit of a blank right here. But to write the factors of our function, since we have our graph and we have our x-intercepts, we can just convert each one of our x-intercepts, our zeros, into factors. So we can either read them from the graph, or it might make sense to just look at them right here where we said where our roots were. And let's just go in order from left to right. If negative 3 is one of our roots, then I'm going to leave a space right here. X plus 3 will be its factor. And if negative 1 is one of the roots, then x plus 1 will be another factor. If 1 is one of the roots, then x minus 1 will be a factor, and if 4 is one of our roots, then x minus 4 would be one of our factors. What we don't know is the value of a. I do know that since this graph ultimately is pointing down in both directions, a is going to be negative, but I don't know what a is. So I'm just going to leave it as an a, but I am going to put negative a because I do know that there is a negative involved because my ends are pointing down. I also want to remind you that there is no multiplicity with our roots, and therefore there are no special exponents on top of our factors. So that is f of x written in factored form. Again, we don't know what the value of a is, we just know that it's negative. Thanks for watching this tutorial, and I look forward to practicing this more in class. See ya.